All right, today we're going to look at the area of parallelograms. It's not a difficult concept. This is a parallelogram, okay? Simple parallelogram. And a parallelogram is just a rectangle that is slanted. All right, so if we put it against paper, you can see a little better. All right, so there's our rectangle. If we slant it this way, it's a rectangle. If we slant it that way, okay, we have a parallelogram from a rectangle. Even if we put it up this way, here's our rectangle, and then we have a parallelogram and a parallelogram. All right, so when we're finding the area of parallelograms, it's still the same as the length times width of a rectangle because they are just slanted rectangles. But, of course, we have to use different jargon. So instead of saying length times width, we say it's base times height. All right, very much like a triangle, we have a base and a height. So here's a parallelogram, all right, in blue, okay? Our heights are in red, okay? So if this is our base right here, okay, I'll call it base 1, okay, and you'll see why in a minute. This base is attached to this height that is internal to this parallelogram here. All right, so this is height 1. These are the two that you would use together in order to calculate the base times height. So if you use this base, you have to use this height because it's touching the base. All right, so that's how you calculate area using that. Let's just turn this around. Here's the base of our parallelogram now. Okay, so we'll call this base 2. So if we're looking at it from this perspective, that would be our base. Our height is not inside. It could be, but instead our height's been drawn outside, external to the parallelogram. But yet at any point, this is how high our parallelogram is. Okay, it's the perpendicular distance to the opposite side. Just our opposite side here is extended a bit. So this is height 2. If you're going to use this base to calculate your area, you must use this height that touches the extended base. Either way, base 1 times height 1 will give you the same area as base 2 times height 2 because it is the same parallelogram. So, I'll write it up simply so you can see, and I'm going to abbreviate base 1 times h1. And then area, if you use base 2, would be times h2, which is the height 2. They are the same. You're going to get the same area. You will not get different numbers. If you do, something's wrong because you only have one parallelogram, and that's what you're taking the area of. Okay, so let's start with the first quick, easy problem. Okay, we want to know the area of this parallelogram. So we have a height drawn inside. It's the perpendicular distance from, we usually draw it from a vertex or a corner of our parallelogram down to the opposite side. All right, and you'll tell that it's a height by the fact that it has a perpendicular right angle box there. So we're going to just take area equals 37 times 10, which is going to give us 370. And this is centimeters, so it's centimeters squared. Let's make that look like a 0. That's your area. It's that quick, that simple. All right, now triangles. Triangles, we know the area to be half base height, but I just want to get you back in the groove here. All right, again, triangles can have a height outside your triangle also. We extend the base and we drop the height. If we were looking at it from a different base, the height would be internal, but we don't have that information. So whatever info you have to be able to work with. So if we want to know what A is, the length of our base, but we know it's 10 miles high and we have an area of 80 miles, we're just going to plug in 80 equals 1/2, because that's a triangle now. The base is A times 10. Okay, so we're going to get 5, so 80 equals 5A. Divide by 5, and 80 divided by 5 is going to give us A equals, that's going to go in once, 16. So our A is going to be 16 miles. That's our answer. That's our base length for that triangle. Okay. All right, so just keep in mind the area of a triangle versus a parallelogram. They're very similar. We discussed a little bit of this the other day, even with trapezoids. So just plug into your rules and figure it out from there. Okay. All right, so let's look back at a parallelogram that we're given an area and we have a height, but we don't know the base, okay? So we're going to be looking for this base here. So area equals base times height. All right, so we have an area of 228. We don't know the base, but we know the height, so 12b we'll keep b for our base, right? And you divide by 12, and 228 divided by 12 is going to give us 19. So our base is 19, and since we have a unit, we're going to put millimeters here. Okay, remember areas have units squared, and your lengths have a unit. All right, let's look at this problem. We want to find the height of this parallelogram that's out here, external to the parallelogram. Now you have to keep in mind that this height here is drawn from the outside. We extended this base here, but it could have easily been dropped in here. Okay, it's the same thing. It's just that it's moved over. So we could have easily put this here, okay? But you should be able to work with what you're given. So we're given this height outside, but if you needed to move it parallel down, bring it over here. That's fine. You can put it inside. Most of the time we don't draw pictures like that because we have a crisscrossing of two heights and it can get confusing. All right, so here we have our base is 14 and it's up here. And we have another base here of 10, okay? So I need to use this height of 8. And the bases that it's touching are this one and this one. So I'm going to bring that 14 down. So 8 and 14 go together. This base belongs to this height of 8 belongs to the 14 base. So area equals base height for a parallelogram. Okay, put a little parallelogram box there. So our area we don't know, but we know we have area equals 14 times 8, and just keep it there for a minute. We're trying to find this other height, so I'm going to turn that around. We have a base here of 10 and we have a height. So this height, h, belongs to that 10 base. So if you wanted to bring it down here, you can. It's an extended base times height. So area equals 10 times h. We don't have a value for area. We want to find out how high that external height is. So 14 times 8 is 112. These are both the same exact areas because it's the same exact parallelogram. So 112 equals 10h. That's really all you have to do. Base times height equals base times height. So now divide by 10 and you can find h. And h will give us 11.2. And the unit on this one we don't have, so you can put just a generic term of units. So that's our value of h. So whenever you're missing a height, you're going to take the other combination of base height and you're going to equal it to the other combination of base height, and you'll find out whatever's missing, whether it's a base or a height. Okay. All right, very quickly, in algebraic terms, if we have a base times height, we want to find the area. It's no numbers, but that's okay, we can still do this. It's x times 2x. So our area in algebraic terms, or an expression, is going to be 2x squared, and it's units squared because it's an area. So it's very simple. It's not difficult. You just got to work with it. All right, and lastly, let's do a combo of a parallelogram and a triangle. So first we're going to do the area of the parallelogram, and I'm going to label it, and that's my parallelogram symbol. It's going to be 21 times 15, and 21 times 15 is going to give us 315, and it's centimeters squared, so that's the area of our parallelogram. Now we need the area of our triangle, which is half base height of the triangle. Now you see this height here of the parallelogram? Well, it's the same exact height as our triangle, so we're just going to move it over here. If you don't need to move it, that's fine, but I usually say move it so you can see it. And so now we can isolate just our triangle, and it's area of our triangle is going to be half of 20 times 21, which is going to be half of 20 is 10. 10 times 21 is 210 centimeters squared. And now we want to put together the area of the whole figure. So I'm just going to put figure here. It's going to be 315 plus 210, which is going to give us 525 centimeters squared. And that's our final answer. Okay, labeling is important, okay, so that you can tell the difference between what you're working with, identify it, and then put it together.